Without graphing, determine whether the following equation has a graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. Here's our equation: y equals negative 2x cubed plus x. Okay, so the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. So what that means here is the following. We're going to replace this y with a negative y. Okay, and then that's going to equal negative 2x cubed plus x. Now the question is, are these two equations equivalent? Okay, well the answer is no, because the y here is positive and this one's negative. So what does that mean? Well, that means the following. That tells us that replacing y with negative y does not result in an equivalent equation. So the graph of the equation is not symmetric with respect to the x-axis. Okay, now let's use that equation again for the second part here. Now we want to check and see, is the graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in equivalent equation. So what that means is we need to replace now x to be negative x. So we're going to replace the x to be negative x, and then we're going to cube it, and then plus negative x. Okay, so what do we get? We get y, which is equal to, well, this becomes a negative x. So this is negative 2 times negative x cubed. And then this becomes plus minus x, which is minus x. So a negative times a negative is going to give us a positive 2x cubed, and then that's minus x. So the question is, are these two equations here, are they equivalent? So are these two equations equivalent, meaning are they equal to each other? And the answer is no. So let's go ahead and write that scenario. So replacing x with negative x does not result in an equivalent equation. So the graph of the equation is not symmetric with respect to the x-axis. Okay, now we want to try the third scenario. Okay, this third scenario is to check whether the graph of an equation is symmetric with respect to the origin. And that's if the replacement of both x with negative x and y with negative y at the same time results in an equivalent equation of the original one. So we know that we're going to replace y with negative y, and then we're going to replace x with negative x. So this is negative 2 times negative x cubed plus negative x. So we get a negative times a y, which is negative y. And then we know from the previous step that this is going to be a negative times a negative, which is going to be positive 2x cubed. And then this is going to be plus minus, which is minus x. Okay, now let's solve for y. So if we solve for y, that means we need to divide everything by negative 1. So that means we get positive y, which is equal to negative 2x cubed. And this negative divided by negative makes this a plus. So can we say that that equation, or are these two equations equivalent, meaning that are they equal to each other? Well, we can see that they are equal to each other. So they are equivalent. So we're going to say yes. Okay, now what do we need to state? So what we're going to see here is that replacing x with negative x and y with negative y results in an equivalent equation. So that means that we determined that these two are equivalent. Okay, so the graph of the equation is therefore symmetric with respect to the origin. Therefore, the graph of the function is symmetric with respect to the origin only. So let's go ahead and then answer that question. So we would say the origin, check the answer, and then there is the result.